welcome to the third video for Factoring Day 1. On this one we take what we learned in the first two videos about the greatest common factor, and we see if we can use greatest common factors for something just a little more complex. So here we have an example, 4 minus 2x plus 6 minus 3x. And we look across here and we see that, well, in these first two terms we have 2 is common to both. So I can take the 2 out. 4 divided by 2 is 2. Minus 2x divided by 2 is minus x. Now I look over here, and what's common to these two terms is a 3. So I take the 3 out. 6 divided by 3 is 2. And minus 3x divided by 3 is minus x. Okay, now I look at these two terms. And of course this is a contrived problem. You're not always going to have it so straightforward. But we're just showing you some opportunities that sometimes arise. So in this case, what's common to both of these terms? Well, the 2 minus x you see in both terms. So we can take that out. So if we take 2 minus x and separate it, this term divided by 2 minus x gives us 2. So we have a 2. And this term divided by 2 minus x gives us a 3. Alright, so now if we look at our result where we separated out the 2 minus x, now I have this 2 plus 3. Well, 2 plus 3 is 5. So we end up with just 5 times 2 minus x. And we've resolved that using greatest common factors. Now let's try a second example. If you have some difficulties with that, you might want to pause the video or return to that. Okay, so now let's pick another example. So I think what we'll try this time, we'll try 3x squared plus 3xy minus 2xy minus 2y squared. Okay, here's an example. Let's see what we can do. What's common? So if I look at these two terms, I see that there's a 3x common to both terms. So I'll pull the 3x out, and 3x squared divided by 3x leaves us with an x. And if I pull a 3x out of this term, 3xy divided by 3x leaves us with a y. Okay, so we've used the greatest common factor there. Now let's look at the rest of it. Well, I see a minus 2 in both cases, so I'll pull the minus 2 out. And a y. I have a y common to both. So minus 2y divided by minus 2y leaves me with just an x. And then minus 2y squared divided by minus 2y leaves me with just a y. Okay, so now I've taken the common, and this here should be a y, not minus 2. So I divided the minus 2y into this term, and I ended up with an x. I divided the minus 2y into this term, and I ended up with just a y. Now what's common to both of these terms? Well, it so happens x plus y is. So I can take x plus y out of there, and if I divide this term by x plus y, I end up with 3x. And if I divide this term by x plus y, I end up with minus 2y. Okay, so this is as far as we can take it with greatest common factors.